Rich Davidson. I was first licensed in 1959, so I've been a ham for about 55 years. I've been practicing as an electrical engineer for companies like Motorola, lately for a company called GoGo, which used to be called AirCell, which puts Wi-Fi on airplanes and links it to the ground with a radio link, or up to satellites with a radio link, which means I get to do ham radio for a living. Is that a great job or what? I'm telling you. Yeah, it is. I'm 68 years old. I'm not going to retire yet. I'm maybe 70. I'll think about it. If you need to know things, the first place probably to look is the American Radio Relay League. I think it's .org. I'm pretty sure. When you send emails, it's .net. But if you want to talk to me, you can actually go send an email to K9RD@ARRL.net. Our club that sponsors this is the North Shore Radio Club, NS, because there's a call district, which we'll talk about, NS9RC, North Shore Radio Club, with that 9 stuck in there, @org. No, wait a minute, excuse me, .org. That's the email address. I'm sorry, that's the web address. It'll be the same thing. Everything was hypertext transfer protocol, World Wide Web. Other places that are interesting are QRZ.com. This is actually a commercial source. That's a place where if you want to look up somebody's call sign, you can. And if you want to find used equipment, you can. So it's a nice little blog site and website for people interested in ham radio. There's just hundreds of these things. There's a place called TABR, the Tucson Amateur Packet Repeater Association. It has just about everything there is to know about a subject called packet radio recent data in the what do you call it, X.25 kind of format, the kind that the internet uses. Radio Relay League, our club, QRZ. There's a good start. Go there. Pretty much it'll take you to other places. All the questions that are, go ahead.
QRZ-ham test. They've got online.
That might be a subset of what's there.
Yeah, they've got online practice exams. I've taken a few of them.
So you're saying there is such a variation on this?
Yeah, it's QRZ.com/ham test.
QRZ.com. Then there's a slash. So this is the sub.
Yes,
page.
Ham tests, not ham test.
Which means get rid of the org part. Hams. I really should do this over. There's a valuable created eraser. So you're saying there's a sub-page called ham test?
Ham test, yeah.
Yeah, okay. I'm sure there's a lot of other sub-pages too, because there's one that has the daily bulletin of the FCC, what licenses were issued after you take your test, and you want to see what your brand new call sign is, that's where you go. It'll take about a week after you take the test for it to show up there, which is pretty quick. I used to wait 6 weeks. In fact, I used to wait 8 weeks when I took the test downtown at a place at 219 South Dearborn before they built the Dirksen building. It was called the U.S. Courthouse, or the post office. It was all one building in the South Loop, and I was on the 8th floor in room 829, and you had to sit in this old government building with the oscillating fans and all that. And when you took the Morse code test, they had an instructograph machine where they put punch paper tape in and used to tap it out for you with perfectly spaced characters, and you had to scribble quickly to pass the general test at 13 words per minute or extra to 20. Those are the days. We have a volunteer examiner system now, so we test all over the place. Back then, only Chicago, New York, and LA had weekly exams. Every place else you had to wait for a traveling circuit of examiners to show up in your area. And if they didn't come within 75 miles of your location, anytime during the year, you could take a conditional test by mail. It's changed a lot, it's gotten a lot better. Oh, what else? Let me, since I think most of the people are here, try to tell what I would normally say in the first minutes of the first class when I do it. There used to be a TV show that was actually patterned after a movie called The Paper Chase. And John Houseman was a curmudgeonly old Harvard professor of law, taught a first-year course called Contracts. And he sat at the lectern and he leaned over and he very condescendingly looked at his students and says, "You teach yourself the law, but I train your mind. You come in here with a skull full of mush, and if you succeed, you go out thinking like a lawyer." Wise words. This is what teaching really is. Not to tell you how to memorize answers to questions, but to teach you how to think. And year was 2005. I was given an award for the 2004 year, actually, called the Herb S. Breyer Award. And it's a national award. It's given to one person every year. I won it that year. It's the Instructor of the Year Award for the American Radio Relay League, voted on by the Board of Directors. So here I am, famously. What did I do to get that? I explained to them in a very long discourse how I teach my class, and I do it differently than probably any other ham class that you normally run into. What I do differently is, don't worry, I haven't really started the class, I'm just kind of introducing myself. What I do differently is, I don't teach the book. And this is the way Professor Kingsfield would have approached this class. He would have said, "You teach yourself the law, I train your mind." Okay, you teach yourself the question pool and the answers there too. And I train your mind by teaching you the conceptual things that the book does not give you, and the things that without which the book doesn't really easily make for good reading. It's a good cure for insomnia, in fact. I'll be the first to admit that. I love the subject, but it would put me to sleep if I didn't already understand certain conceptualizations that the books, no matter what they are, don't bother to go through. So where did I get that kind of notion? I got it by just being an electrical engineer, studied at the University of Michigan. That's where I got my degree in engineering. And discovered that, the class isn't there to read the book back to you and say, okay, let's talk about what's on chapter 23. Let's look at the first and second, third paragraphs. They do that, by the way, in another course that I teach, and I have to follow their format, for marine electronics for the United States Power Squadrons, which teaches boating. They expect that you will read the book, your instructor will talk about the book, you'll get homework, you'll answer the questions, and they'll refer specifically to material in each chapter, and that's how you're going to learn the materials, by doing a think and do exercise like you did in grade school. You read the story, you remember the facts of the story, you answer the questions, and that's how you kind of absorb the material. It just doesn't work in electronics. It's not memorization, it's understanding, it's conceptualization. So that's what I'm here to teach. If you want to get that license, you're going to have to spend time with the license manual, or just the question pool if that's all you think you need, and it might just be enough. And that question pool you can get by downloading it from the league, or I could be generous and just attach it to an email and send it to you, since they've given me all your email addresses. And you'll have it. And you'll have that as your study material in prep for the test, in prep for the understanding of what I teach. You really should get the book, the license manual, and see what they say after I teach you how to understand what you're about to read. By the way, anybody here that has not been here before, like who wasn't here last week? Anybody? Let me pull up the previous pages and just have you add to it. What I need is a roster, not so much because I care who shows up and who does not, and I do not take attendance, and I do not give out homework. Here's a pen. And I don't give quizzes. You're going to get one exam, and it's going to be in the final week, and that's it. And it's not a test that I devised, it's one that the government devised. So I'm not concerned whether you make it here or not. You can actually watch the video if you choose, but you'll do more, because you'll see the board more clearly if you see it when I present it. you'll be able to ask me questions if you're here live. I need that because sometimes I travel, sometimes I can't make the class, just like I couldn't make it last week. It's helpful if I can tell you that. Last week was a disaster because it was the first class. I don't know who comes until they show up. So by not making the first class, I was in a real pickle. And Michael will remember the panicky voice from Atlanta when I called and said, help. And then I got Greg Laban, who's a former assistant professor at Northwestern, who's a club member, or was a club member, and he volunteered to help me out. And he's taught for me before. Okay, that's the intro. Let me try to plug a few holes. I watched Greg's video. I spent till about past midnight last night watching all 7 episodes, so I know what he said. Let me tell you what I think he didn't say that he should have, or could have, doesn't matter. He has his style, I got mine. And try to build a foundation for everything that follows. The stuff in the first class or two is really the most important because it's the foundation on which everything else is going to be based. You have to understand a little bit about basic electricity and circuits in order to be able to fathom everything else. And I will cover everything else. We're going to build a circuit or two. Probably I'll start with a power supply. It's a great one because it has a transformer, it has a rectifier, it has a filtering network, it has a voltage regulator. It's just a great combination of things. You've got coils, you've got diodes, which are nonlinear devices, the only ones in the network that are typically. You got filters that are made with conductors, resistors, inductors, capacitors, and you got a regulating circuit which uses a transistor. Wonderful device. Sounds complicated. None of these books teaches you anything about the transistor and really how it works. I'm going to cover that. You will know how a transistor works when I'm done. So you're going to get from this course all the things the book doesn't get and you really do need to get where you want to be. Let me start out picking up on what Greg was doing. In fact, I'm going to go even back to an earlier point. I'm going to build what looks like a picture frame. Think of it as a water pipe. It's filled with water. And the water's not doing anything because there's nothing to make it move. And if I insert a pump and put a pulley on it and attach it to an electric motor, and the motor spins, the pump turns, what do you think will happen? Water will flow. Observe. An arrow with a closed top means current flow. Now, we'll just keep doing this until I make life a little difficult here. Insert another gadget here called a valve. And just like Greg said last week, when we talked about resistance, resistance is sort of a pipe that instead of being this big is maybe that big, so water has a harder time going through it. You don't get as many gallons per minute flowing through a narrow pipe as you do through a larger one. So your half-inch pipe doesn't conduct as much water as a 2-inch pipe does. Same thing with wiring. The bigger that conductor, the big cross-section in it, the more current can flow through it without warming up that conductor and without getting, you saw this symbol already, the resistance felt. Now I'm going to do one thing other than what Greg does. I'm going to try to throw a little more formulation, and not because I think you should memorize it, but because I just want you to think about the concepts. I'm always talking concepts. Resistance is resistivity, this letter rho, divided by cross-sectional area, which means the bigger this is, the more cross-sectional area, the lower the resistance, because the number in the denominator getting bigger makes the number get smaller. The resistivity, if it goes up, meaning something has more resistivity, copper has more resistivity than silver, iron has more resistivity than copper. Things that are more resistive have more resistivity. the resistance will go up because it's in the numerator. Concepts, right? Okay, so the water's flowing in this pipe. The valve's open, nothing's gonna change until I start constricting that valve. And now, all of a sudden, the flow is going to go down, and what you're gonna get is a higher pressure on this side than on that side. The water flows in, it starts backing up. It's harder to push the water through the valve in the pipe, and you get a higher pressure on the intake side than the outtake side. Makes a little sense, doesn't it? How did that happen? Well, you had to have a higher pressure here to make the water flow in the first place. That was that E, which stood for electromotive force, that if this were an electrical equivalent, not water in a pipe, would look like this. Oops. Hey, Rudy Giuliani once said, when he heard about artistry, one of the people being art critics, is art is whatever an artist does. If I did it, it's not art. Okay. As you'll quickly discover. All right, so the equivalent in an electrical circuit is this. You got a voltage source, and you got a resistance, and a current flows through it, closed arrow. And what do you think happens? There is a higher something on the intake side of the resistor as on the outtake side. Just like here, the water trying to get to the valve, backs up on this side, higher pressure here than there. You have a higher potential, that's the word, on this side. And what you really have between those two things is what's called a difference. Of potential. And that, by the way, is what a voltage is.